Okay.
We use this room for cooking.
Okay, great. So,
but there is no light.
well, what I'm going to do first is I have this instrument that when I turn it on, it starts to count the particles in the air, so like the smoke. It tells me how many and also how large they are.
Micrometer.
Right. So
in
5
micrometer.
5 micrometer, 0.3 micrometer.
From 0.3 up to 5.
Up to 5. And so, while cooking is not happening, I will take what we call a baseline reading. So basically, I will see what the air is like when cooking is not happening. Okay. So, I will go in there if that's okay.
No problem. You can go there.
Okay.
You can open the door?
This is okay. This is just great. And so I've started to count, and I'm getting these readings for how many particles are in the air. This is actually pretty good. This is good right now because cooking isn't happening, so there's not much in the air. So this is great.
Quantity of what?
This is a number of particles per liter. So you think of like a 1 liter bottle. And so this is 127,000 particles that are this size, but that's not so many compared to when you would see, if there was a lot of smoke. So this air is not so bad. And so down here, it's a little hard to see, but you say cooking happens in this room.
We can bring the chocolate.
Bring the what?
The chocolate for cooking.
Ah, okay.
Not yet.
Okay, not yet. But yes, so the good news is that it seems like most of the particles, when you're not cooking, they leave this space. They don't stay around for very long. So that's good news. So I just took another baseline reading, and I'm writing that down now. The interesting news is that inside of that kitchen there isn't a terribly large number of particles that's accumulating. It's really not so different than outside. The particle counts are higher for like the 0.5 and 0.7 microns, but not to the level that we were seeing before. That might suggest that there is something about the construction of the house that lets the particles leave a little bit easier. So we should definitely look at that and try and figure out why. There are a large number of large particles which are of less concern because typically that's like dust and such. But typically those are the ones that are less harmful. Do you usually keep the coals lit all the time? Is the fire always burning here?
Late or at time?
I'm sorry, what?
You say that?
I was wondering, is this always lit? Is this always burning?
They come now for outside.
Ah, okay, I see. And how long normally would you cook? Yes.
Sibori. How long we use this in this room?
Yes.
Anytime we cook, we use this.
Okay. Is it 1 hour, 2 hours, 3 hours?
It depends.
Okay.
If it is night, we use 2 or 3 hours.
2 or 3 hours. Okay.
The night we cook outside.
Okay. Where do you get the charcoal?
We buy this.
From a store or
there.
From a market? Okay.
There is a small market there down.
Okay. And this stove, did you make this stove or buy it?
Say.
Did you make this stove or did you buy the stove? This here.
This we buy.
Where do you know where it is made? where it is put together?
The amounts.
Who makes this, like, who builds, or...
Well, let me get
Okay.
Abraham.
Ibrahim was at first.
Yeah, we need.
Oh, you see, you want to live with that.
I think we just need a little translation.
Sikiliza kwanza biko nasema.
Okay. I was...
Can you repeat?
Yes.
Yes.
I was wondering if he knows who makes the stoves.
Who makes the stoves?
Yes.
Yeah, it's this one.
Okay.
Yeah.
Ah, okay.
Yeah.
And let's see. So, how many times do you cook each day?
Each day, we use 2 or 3.
Maybe 2.
Maybe 2. Okay.
Twice, yeah, twice a day.
And
It depends of the time.
depends on the
Night
time.
or
And
the,
the possibility.
and
Yes.
the possibility.
Yeah.
Okay.
Normally, we use this in the morning for
Okay.
tea and for lunch and evening. But sometimes you don't have money to buy some foods. You cook once or twice a day.
I see. I
Yeah.
see. What do you normally cook?
Beans,
Beans,
potatoes,
potatoes.
maybe
Sometimes rice.
maybe rice. Sometimes rice, if they got the money, and meat or vegetable.
Okay. Do you grow any of this here?
Yes,
Okay.
except rice.
Except rice.
Except rice.
Ah. So I will take another reading here now that it has been burning for a little while, and I will see how it is different than before when there was no fire.
With the previous measure.
Yes, yes. So I will look at the difference. So the fire has only been burning for maybe a few minutes, but some of the particles, especially the smaller ones, are starting to increase. So there's a little bit of smoke accumulating, but this is a smaller fire, so it looks like maybe the smoke isn't quite as much. Also, it looks like, it's hard to see, but it looks like the charcoal is making less smoke than the wood, which makes sense. So I think the charcoal is a little bit cleaner burning. And I also think I noticed on this...
And when they open the windows,
Mhm.
I think some smoke go outside.
Do they open the windows when cooking?
Sometimes, yeah.
Okay, sometimes, but
Yeah.
not always.
But it's rain at night. They don't.
So if it's raining or at night,
Yeah.
why not at night?
In the evening, 7 p.m.
Okay.
Yeah.
Why would they not open the windows at night?
It's clear,
Okay.
no mosquito.
Ah, yes.
Yeah.
Okay, mosquitoes.
Yeah.
Okay. Great. Thank you. I will write this down.
Finish?
Yes, yes. So what I'm doing right now is basically taking a baseline reading of the air quality that's sort of like outside of the children's home and away from the kitchen. by sort of getting this baseline, we have a good way of comparing what the air is inside to outside. Because an evacuation system won't really do any good if the air quality inside is the same as outside. We need there to be some kind of differential to justify doing that. So basically, I'm standing out here and using this device. It's called a MET1 HHPC6, and what this device does is it counts the number of particles in the air and lets you know how many particles per liter there are just sort of floating around that we're breathing. It breaks those down into size ranges from 0.3 microns up to 5 microns and above. And the size has a lot to do with the health impacts of the particles. The small particles are the ones that carry the most potential for harm. But this device lets us see how many particles there are in a wide variety of size ranges, so we're really getting a lot of information out of this device. Okay, so what I'm going to do now is just take another reading as some of the cooking is getting started, just to see what the difference is. It'll give us another data point between before they've started cooking and when cooking has sort of started in earnest. And just a very brief look at the numbers says that they're already going up pretty dramatically. And we can kind of see that visually in some of the haze. When you look down that hall towards the firewood, you can see some of the smoke escaping. Right now it looks like it's escaping through the doors, through the windows, and also through that hole up above the cooking pots, which I believe that hole was put there for that purpose. So here I'm going to take another measurement because right now we've just put another pot on the fire and a whole lot of smoke came out. And I was just learning that I think some of the large volumes of smoke come from the bark around the outside of the trees, which they also burn in addition to the hardwood in the middle. And it's sort of been described to be kind of like paper. So when that goes up, it produces a whole lot of smoke that we can see now. The other thing that we can see is that, well, it's starting to smell a little bit like onions as well. You can smell the food. It smells great. So the smoke in the background has gotten to be really, really dramatic. There's a new pot on the stove. A lot of bark is being burned, and that's generating even more smoke than the hardwood that's in the middle. So we're seeing it mostly coming from this far burner over here, which is escaping a little bit through that corner, but it's farther away from this hole here, so not much of it is escaping that way. The smoke is sort of starting to burn the eyes a little bit. So it's substantially more than we were seeing before. We're almost maxing out the particle counts that this device can measure. So I'm standing next to a water tank right outside the kitchen now. You can see some of the smoke billowing out from the openings in the kitchen wall. And what we're seeing is, even though we're completely outside the building, the smoke here next to this water tank, where people might be getting their drinking or washing water, is actually causing the fine particulates especially to be almost exactly the same out here as they are inside, which is kind of startling. And I have to say, I didn't expect that the difference in air quality from like out here to inside while cooking is going on would be so negligible. So that's interesting, and we're really going to have to reflect on that if we do decide to design an evacuation system, because if we're pumping the bad air from inside out into places where kids might be playing or people might be getting their water, then, is that actually a good thing to do? So we'll have to really think hard about what we actually do with the air once we've evacuated it from the cooking space. So what I will do first is I have this machine, and when I turn it on, it sucks air through this tube, and it counts how much smoke there is in the air. So these tell us how much smoke is, or other like dust or pollen or particles are floating around in the air. And we will take this reading, and then later, if there's a fire here, we will make another reading, and then we will see what the difference is. So now I have these numbers, and I will write them down so that I do not forget them.
You can sit here.
Yes. Oh, it's okay.
Don't take pleasure.
Thank you. Thanks. So, oh, it's okay. It's okay. So I just took another baseline reading, this time inside another house, and what I'm seeing here is actually that it's about the same concentration as we saw in the previous home. What will be interesting is to see what the difference is between this house and the other one when there's some fuel burning. There we go. So great, this is baseline inside. Okay. Okay. So I think for this one, I'm going to take a measurement right over top of this stove, because it's the same type of stove that we saw in the other house. The lighting is better here, so we can really see that there really isn't much visible smoke coming off of this. So I'm going to try and suck some air right off the top and see directly what kind of smoke this is outputting. And wouldn't you know it, the readings that I'm getting are actually almost cleaner than the ambient air. I'm really not seeing many particles coming off of this. That's a second confirmation that charcoal is actually pretty clean burning compared to wood. So I'll write that down as well. And then I may take one more after it's been burning for a little while, just to be sure. Now my guess is that because this charcoal has been burning elsewhere for a little while, it may be that most of the burnt stuff that was going to float out because of the heat has already done that. But we need a few more readings to be sure about that.
barashaka amavarisi ntabyo uzi mama ndaraga bikubwiye reka twatangiye akazi.
Okay. May I go inside?
Yeah.
Yes.
Thank you. Okay, so it looks like this is the stove here. Right, we good? So this is the kitchen. What I'm going to do first is take just sort of a baseline measurement of the kitchen before the fire is lit to sort of see what the ambient particle counts inside are. My guess is that we'll see something pretty similar to what we saw before. Actually, interestingly enough, this may be because we're on a slightly different day, but the air here actually appears to be much cleaner. We're getting about 62,000 small 0.3 micron particles. That's in comparison with the 200,000 or so particles that we were seeing on previous days. It's going to be a little hard to tell whether that's because we're on a different day and the weather is a little bit different, or whether that's because this area in general just is farther away from traffic and other pollutants. This is a new day and house number 3, and the inside ambient counts appear to Yeah, at least the small particles are about half of the concentration that we were seeing inside some of the other houses yesterday at Nyachonga. The other particle counts actually appear to be about the same. It's just for whatever reason the small particle counts have been cut in half. So that's really interesting. All right. So, taking a reading outside, we see that the air is a little bit cleaner. Most specifically, the 0.5 and 0.7 and 1 micron particles are all slightly less than they were inside. That's to be expected. We're kind of up on a nice hillside up here, and probably the wind is kind of blowing away a lot of the larger particles. So one thing that I haven't seen before are these baskets that they're using to hold the charcoal. Looks like they're made out of wire. And there's one that's holding this charcoal that's burning right now. So far this stove is most similar to the one that we saw at the Rukundo children's home, except it's sort of in miniature. It's got 3 places to hold 3 separate pots, and in general sort of the burn space is much smaller, which sort of makes sense you know, for a personal home. But actually, so earlier we saw the fire being fanned with a plate, and that was kicking up a whole lot of dust. It's actually kind of amazing how quickly all of that has settled, and that's typical of large particles. But whereas before I could kind of taste it, kind of feel it in my lungs, now it's actually not so bad. I'm right next to the charcoal and my eyes aren't burning. It's certainly hot. It's very hot here, but you know, it's not. It doesn't feel as unhealthy as some of the other homes that we've been in that have been burning with solid fuel. So I'm going to go ahead and take another reading, and I'm going to go ahead and just put this right over the charcoal and see what we're getting out of that. Because if this is in keeping with what we've seen at other homes, we're not going to see many particles at higher concentrations than ambient above this coal. Alright, so if I'm comparing that to what we saw yesterday, these numbers actually match up remarkably well with the measurement that I took on top of the charcoal at one of the houses in Nyachonga. We're seeing a few more small particles, but again, they pretty much match what we saw from the house previously, so that's great. We have 2 matching data sets. So we're pretty much at the end of our trip now. We've seen a wide range of different types of houses, different stove types, different fuel types. We've got a ton of data. We've collected readings at each of the places that we've been, both before, during, and after cooking. And I think that we have a pretty good initial sense of how cooking works, both here and in Uganda as well. And it's great. Now we have all of this data. We have to pack it all up, take it home, and then try and come up with some good ideas from it. We're going to have to really put our heads together to come up with the right conclusions from the information that we've gathered. But so far, I think we've confirmed a few things that all of the research that we've read prior has also suggested. Coal makes a whole lot less, or makes many fewer particles than wood fires, and we're seeing that predominantly in areas around the city. We've also gotten, just beyond the numbers that we've collected, we've gotten a good sense of the practices, the schedules, and the attitudes towards cooking. So with any luck, we'll take all of this home, and we'll come back soon with some ideas to try out.